Hello. Let's start a new example. In this example, I'll consider screening tests for birth defects. I made up this example from my own experience. My son is now 4 years old, and when my wife was pregnant, uh, we went through this process at that time. So I also I guess some of you may find this information useful, or will find this useful in the future when you when you go through the same experience. Okay, let's think about this. During the pregnancy, there are many tests like blood tests, ultrasound tests, and many different types of tests to detect the birth defects. You may decline the test if you don't want to know it before the baby is born. That is an option, but typically many uh, pregnant women just want to do it, and we wanted to do it. And the examples of birth defects include the Down syndrome and spine and brain problems, and many others with many more difficult medical terms. But the Down syndrome is the most common and most common type of birth defect. And from the screening tests, positive results imply that the baby is at a high risk of birth defects, some kind of birth defects, and negative result implies the risk is low. You may just simply assume that it's about Down syndrome. And the result is not only about one test. It combines the ultrasound pictures and several other things, and the doctor tells you what's the case. And one background knowledge is that in medical terms, there are the major difference between diagnosis and screening is that the diagnostic tests are to confirm the presence of a medical condition with certainty. But the screening tests cannot confirm the presence, but it only detects a potential risk. There is a risk of a certain medical condition, so the positive result from the screening test may require additional diagnostic tests to confirm the presence, to confirm the condition. So simply speaking, screening test is not a sure thing. It doesn't say you do have something, but it just says you have some risk. So it is about the risk, not about final sentence, final confirmation. So then we are going to denote 3 events this way. D means the baby has some birth defects or Down syndrome. P means positive result. N means negative result. And when I had my son, when my wife was pregnant, we were told that my baby was at a high risk. So the doctor explained several markers. So from this, they imply high risk of the Down syndrome. So then let's think about this. At that point, what we have to calculate is the probability, given the positive result, we would like to calculate the probability that my baby does not have that condition, medical condition. That's what we hope. Then what is that probability? Let's say you can denote, using our notation here, you can denote this probability as a conditional probability. So think about this. And do you answer? I will show you the answer. The answer is C. The event, the condition, the event that already happened is the positive result. The positive result is the condition. It already happened, and given the positive result, what we want to calculate is the probability that my baby does not have birth defects. So D complements the case that D does not happen. So yeah, like we want to calculate this guy, this probability, and of course when you hear the positive result, and when you listen to the doctor's explanation, the doctor tells us what is the Down syndrome and what implies the risk for the Down syndrome, and then the doctor told us how accurate the screening test is. So of course it's about, okay, this screening test is very, very accurate. So it sounds very scary. And when it's from my actual experience, our doctor told us the accuracy of this screening test is, say, 99 point something, very accurate. And that is measured as the probability of positive result when the birth defects actually exist. So when there exists a medical condition, the screening test turns out to be positive, which is the correct result. And this probability is referred to as the detection rate. Then, if you understand what I said here, when there exists the medical condition, the screening test has to be positive. If that's the case, its probability is called the detection rate. And in our notation, what is the detection rate probability? What is the detection rate? Think about this. Okay, if you have not answered this question yet, pause and think more about the question. You have to answer it before keep watching this. The answer is B here, because the probability is calculated this way. We know that if you assume that there exists the medical condition, then given that condition, the probability has to the result has to be positive. What is that probability? So the main event is the result of the test. So given the condition, what is the test? So that's the difference. We want to know probability of D complement given P. So condition is the result. We know the result, but we don't know our baby. But when the medical researchers make the test kit or the test materials, or do the research how to study how accurate the test is, they are using certain samples that have the medical conditions, and then see how many of them turn positive. So as you see, this conditional probability, the conditional probability we need is different from the conditional probability my doctor told us. So we are going to study how to how not be panicked, how not to be panicked in that situation. I will tell you, I will show you. You don't need to be shocked. So we think about 4 different cases. So there are 2 types of medical conditions. Birth defects exist, birth defects do not exist. And if the birth defect exists, positive is the correct result. So we call this true positive, right? Correctly detected the risk. But if the result is negative, then it's a false result. It's wrong. It could not detect the problem. So we call this false negative. Similarly, when there is no medical condition at all, no defect at all, then positive result is a wrong alarm. So in this case, we call the positive result as the false positive result. It is wrong. And in the same sense, the negative result is the correct one. So we call this true negative result. So there are four possible scenarios, and in the medical science, there are two common measures of accuracy of the screening tests. One is called detection rate, which is what I just explained. It's a probability of true positive given that the medical condition exists. So bring the samples, like say blood samples from Down syndrome babies with Down syndrome, and calculate and do some tests and see how many of them have positive result. If it is 100%, if this is 100%, then the positive result, whenever the medical condition exists, the positive result, you will get the positive result. There is no false negative, which means the test is accurate. And in some fields, it's called sensitivity. I don't know exactly which fields use what, but that does not matter. I'm not teaching you these names. And on the other side, also there is a measure of the true negative probability. So among the samples, blood samples of babies without birth defects, do the test and see how many of them become negative results, generate negative results. They are called specificity or selectivity rate. I don't know why they are named this way. So anyhow, if this is 100%, there is no false positive. Then think about this. Think a little more about this. What is interesting here is, suppose that the detection rate is 100%. So whenever there exists the medical condition, the test will be positive. That means detection rate is 100%. But it does not imply whenever you get a positive result, the medical condition does exist. That is wrong. Because, so if you put this as a condition, T as a condition, and 100% detection rate implies there is no false negative. But that does not imply false positive does not exist. So there may be, even if detection rate is 100%, still there may be some false positive results. So because of them, even if you get some positive, even if you get a positive result, still you are not sure. It may be false positive, right? So 100% detection rate does not imply 100% certainty when you get a 100% of defect when you get a positive result. So it's very tricky. I'm going to stop this video here, and we are going to use more specific numbers to see what's going on and how we can handle this tricky problem. See you in the next video.